MS Ramaiah University of Applied Sciences.
Hi students, let us discuss an experiment to design monostable and astable multivibrators using IC 555. The aim of the experiment is to design, build and test the performance of an astable multivibrator and monostable multivibrator using IC 555. The design of astable multivibrator and monostable multivibrators are shown here. This particular experiment is designed for frequency 1 kHz and 50% duty cycle. The circuit diagram of an astable multivibrator and its output waveform is as shown in the figure. The output of an astable multivibrator is a square wave. During the positive cycle, the capacitor charges, and during the negative cycle, the capacitor discharges. The circuit diagram of monostable multivibrator and its output waveform is as shown in the figure. The output of the monostable multivibrator is a square wave. The capacitor starts charging when the triggering pulse is given to pin number 2 of IC 555. The result obtained in terms of output voltage, T on and T off, is measured. T on is the time of the signal at positive cycle and T off is the signal at negative cycle.
Hi students, today I am going to explain the experiment of multivibrator in that astable multivibrator and monostable multivibrator. Now I am going to set up the experiment of astable multivibrator. So the required component for astable multivibrator are the digital oscilloscope. This is the digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button. So to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as the channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. This is DC regulated dual power supply. In that we have voltage terminals and current terminals. So these two terminals are used to set up the voltage. This is a coarse tune and this is a fine tune terminal. So this is positive and this is negative. This is the current setting terminal. So this is the switch to switch on the power for DC dual power supply. Similarly, the same setup that will be in the other side. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is the series connection. So this is the series connection in x-axis and this is the series connection in y-axis. Till this division that will be counted to 5, till that it is a series connection. After that this is one connection. Capacitors. Here we are using two capacitors. One is 0.1 microfarad, another one is 0.001 microfarad. Resistors, we are using two resistors. One is 3.6 kilo ohm and another one is 7.2 kilo ohm. This is IC 555 timer we are using in the multivibrator experiment. From the notch, this is the notch. From the notch on the left hand side, you need to count the numbers. This is pin number 1, 2, 3, 4 and 5, 6, 7, 8. Connecting wires. These are all the connecting wires to connect the circuit, and patch cords. This is the patch cords that will be used to connect the input and output devices to the circuit. Now let us start the circuit connection of astable multivibrator based upon the circuit diagram. Take the breadboard and mount IC 555 timer on the circuit board like this. See, I mounted the IC 555 on the circuit board. 1, 2, 3, 4 pins at left side, 5, 6, 7, 8 at the right side. I am taking 7.2 kilo ohm resistor and I placed that 7.2 kilo ohm resistor in between 4 and the terminal 7, between the terminal 4 and the terminal 7. This is terminal 4 and this is terminal 7. I placed this 7.2 kilo ohm in between the terminal 4 and the terminal 7, and I want to make terminal 4 and terminal 8 as a short. So this is terminal 4 and this terminal 8, I made it as short. Next I need to connect some 3.6 kilo ohm in between 7 and pin number 6. So pin number 7 and pin number 6 is this one, 4, 5, 6. This is pin number 6 and this is pin number 7. In between these two I need to connect one 3.6 kilo ohm. See here I connected 3.6 kilo ohm in between the pin number 6 and the pin number 7. Now I want to make pin number 6 and pin number 2 as short. Pin number 6 and pin number 2, I need to make it as a short. This is pin number 6 and the pin number 2, I made it as short. Next pin number 5 and 1, that will be connected with 0.01 microfarad. So this is 0.01 microfarad. I need to connect this capacitor in between 1 and 5. So this is my pin number 1 and this is pin number 5. See here the capacitor that will be connected with pin number 5 and to pin number 1. I will make the pin number 1 to ground. Okay, this is pin number 1 and that will be connected to ground. Then now I am going to connect the 0.1 microfarad to ground from the terminal number 6. So this is terminal number 6, 5, 6, this is terminal number 6. This 6 to, I connected somewhere in the circuit board. You see here I connected an external point in the circuit here to here, and I am using another wire to connect to it into ground. So this is the ground connection. Now I want to give the power supply connection for this. I am using DC dual power supply to give the power connection. The positive of the DC dual power supply. Now I am going to give the power supply connection from DC regulated dual power supply to the pin number 8. This is pin number 8. You see here I am connecting this into here. The negative of the power supply is given to ground. So this is the ground connection I given here. Next I need to connect with the output. To see the output, I am taking the patch card and I connect it to one of the terminal in the digital oscilloscope. The negative of the digital oscilloscope terminal will be connected to ground. And another terminal will be connected at the terminal 3 to see the output. Terminal 3 I need to connect You see where is terminal 3? This is 1, 2 and 3. This is terminal 3. This is the output port. I connected that into terminal 3. See here, it will be connected to terminal 3. The output channel will be connected to terminal 3 and ground. This completes the circuit connection of A-stable multi-vibrator. So now you switch on the digital oscilloscope. And DC dual power supply. For A-stable multi-vibrator, we don't need any triggering pulses to execute the waveforms. So it is automatically, we have to adjust the DC dual regulated power supply, then we are getting the signal at the output side. Now I start to adjust the DC dual power supply regulations. So you see here, so if you try to adjust to some point, you will get very good accurate result. You see, this is the output of A-stable multi-vibrator. So here we need to calculate what is the duty cycle. So T on and T off time. So when that will be on condition, the signal will be on, the time the capacitor will be charged, that is called as a T on time. When the capacitor start to discharge in the off time, that is called as a T off time. So now you see the T on time is more than T off time, around 1.1, 0.2, 0.3, 0.4, 0.5, 0.6. So 60% on time and 0.1, 0.2, 0.3, 0.4. The 40% of off time. So 60% on time duty cycle and 40% off time duty cycle. So you can calculate the total duty cycles to 100. So this is the output of A-stable multi-vibrator. Dear students, we already discussed about the A-stable multi-vibrator. Now I am going to explain the monostable multi-vibrator experiment. So to demonstrate this experiment, we need the components are the signal generator, DC regulated dual power supply, digital oscilloscope, circuit board, IC 555, one diode. This is the diode we are using. In this diode we can find one silver color here and one the black color backside. So silver color that will indicates the negative terminal of the diode and the black color that will indicates the positive terminal of the diode. 10 kilo ohm 2 resistors, 3 capacitors we are using. One is 0.1 microfarad, 0.01 microfarad and 0.001 microfarad. Connecting wires and patch cards. Now let us start the circuit connection of monostable multi-vibrator based upon the circuit diagram. Now I am taking the circuit board and IC 555 timer. I place the IC 555 timer on the circuit board. Anywhere in the circuit board you need to connect this one. There is no problem for that. So next I need to make it as a short, the pin number 4 and 8. So this is 1, 2, 3, 4, fourth pin. With 8th pin I am going to make it as a short. Now this is shorted. Next I am going to connect this shorted pin with the number 6 with 10 kilo ohm resistor. So I am taking one 10 kilo ohm resistor and I need to connect either 4 or either 8. So this is pin number 5, 6. This is pin number 6. This pin number 6 that will be connected with 10 kilo ohm resistor with a shorted to 4. This is 4. This is the 4th pin. So here it will be connected. Next, and to connect the pin number 2 with the pin number 4 or pin number 8 with 10 kilo ohm resistor. I take another 10 kilo ohm resistor. 10 kilo ohm resistor I am taking. So this is pin number 2. Pin number 2 I need to connect. That will be shorted with either 4 or either 8. I am going to short with it 8. This pin number 8 I am going to short it. So here it will be connected. Next, in the same way, I am connecting the diode. The negative of the diode that will be connected to pin number 4 and the positive of the diode that will be connected to pin number 2. So this is negative and this is positive. So here I am going to connect like this. With this pin. Now it will be connected with parallel to this resistor 10 kilo ohm. Next I am going to connect to the capacitors. The 0.001 microfarad capacitor that will be connected the pin number 5 and the pin number 7. First I connect the pin number 7. This is pin number 7 and pin number 5 I need to connect. This is pin number 5. This connection will be over. Next I am taking 0.001 microfarad to the input from the terminal number 2. So this is terminal number 2. I am taking this capacitor and I placed it somewhere in the circuit board. Somewhere I created one point to connect the input. And 0.1 microfarad I am taking. That will be connected to the 6 to ground, the terminal number 6. This is terminal number 6 to ground. I need to connect. I create the ground somewhere here. This is ground. Now I am taking the connecting wires to connect the DC regulated power supply. The positive of the DC regulated power supply will be given to the pin number 4 or 8. Now I am giving this to pin number 4. This is pin number 4. I am giving somewhere here. Next the negative I am going to connect to ground. Negative I connected to ground. This is the ground. Next, take the patch cord to connect the input from the signal generator. So this is the input of the signal generator terminal. So positive end that will be connected to the capacitor of the one end what we are leaving freely. So you connect that to this point. The negative you made it into ground for a ground connection. Next, take another patch cords to connect the output devices. So I am connecting one terminal. The positive of the terminal I will connect it to the input. Positive of the terminal I connected to input signal connected point. So this is the input signal connecting point connected here. So the negative I made to ground. So you are relieving. Next I am taking another patch cord to connect the output. This is channel 2, I connect the output. The positive of this wire that will be connected to the pin number 3. So this is 1, 2, 3. This is pin number 3 somewhere here. This is take the patch cord to connect the input from the signal generator. So this is the input of the signal generator terminal. So positive end that will be connected to the capacitor of the one end what we are leaving freely. So you connect that to this point. The negative you made it into ground. This completes the circuit connection of monostable multi-vibrator. Now I am going to switch on the signal generator, DC dual power supply regulator and digital oscilloscope. Now I am going to adjust this into square wave with the frequency of, just click on frequency of 300 Hertz, and I need to fix the amplitude. So just go back and you click on the amplitude. This is an amplitude of 2.5 volt peak to peak. I adjusted. So now you switch on the channel. So I'm going to adjust this to 5 volt. So you want to see the output, you connect this output port to the pin number 3. So you can see that the negative edge triggering at the output signal. Now if you want to see the charging and discharging process of this, you have to remove this connection from the pin number 3 and you place that into pin number 5, 6. Next you take another wire and you connect it to pin number 3 and you connect the input to this terminal, and you can see the comparison of charging and discharging process with the output terminal. So when it comes under positive sign, the capacitor will be charged, gradually it will be decreases to with respect to the input signal. This completes the monostable multi-vibrator experiment using IC355 timer.
At MSR UAS, we spark your imagination unlike any other.